Welcome to Taxonomy Online Mathematics, a place where we learn and relearn mathematics. We are on the indices, and today we are taking exponential equations. Now, when we talk of exponential equations, we already know what equation is. It's just mathematical statement that involve equal sign. So an exponential equation is just any equations that involve powers of numbers. Any equations that involve powers of numbers. So we are saying that any equations that involve powers of numbers, for example, if I have 3 exponent x equals to 9, because of the equal sign having two sides, we are having equation. But because we are having a power or an index to any number, we call this exponential equation. Or we can also have 7x minus 1 equals to 49. This is also an exponential equation because we are having equal sign. Yes, it's an equation. We are having a base and an exponent. So this could be our example. Now, if you have questions of this form, as in 3 exponent x equals to 9, and I am asked to find the value of x, what value of x make this statement or this equation true? What are the procedure or steps that I'll follow? One of the steps is that you have to make sure you express each of the numbers, every number present in the equation, as power, as in a base and an exponent. So if I'm talking about this, then it means that we can also convert this into a base 3, a number in base 3 with a certain exponent. So the steps are, so we are saying 1, express all the numbers as exponent of the same base. 2, express both sides as a power of the same number using the laws of indices. Then equate the exponent and solve. Number 3, equating the exponent and solve simply means that if we are having a exponent x equals to a exponent y, where a and y, a is not negative number or 0, then we can say that x is also equals to what? Y. We are to equate after you express each of the numbers given to you having the same base. If they are having the same base, then you are going to equate the exponent. We are going to equate the exponent. We can say that a equals to a. Therefore, x must also equals to what? Y. That's the meaning of what? Equating the exponent to solve for the equation. So now, for example, if what we are having here, if we are having this as we have as an example, we have to find the value of x. First of all, we have to express each of the numbers to have the same what? Base. So it means we can also express 9 in base 3. Meaning 3 times 3 times 3. How many times will produce 9? And we know that this is going to be 3 exponent what? 2. 3 exponent 2 give us what? 9. So if we are saying that 3 equals to 3, then we are going to say that our x is also equals to what? 2. So if this equals to this, it implies that x also equals to what? 2. So all you need to do is to try your possible best to express each of the numbers to have the same base. If we want, for example, this, we have, if this exponent, this equals to 49, we have to find the value of x. Now, since I'm having a base at 7, normally the bases that we use as the simplest form will be the bases that are the prime numbers. So we can see 7 is a prime number. So I am going to maintain 7 exponent x minus 1 equals to, then I ask myself, if I am multiplying series of 7, how many will I multiply in order to get 49? And I believe you know 2. So that means 7 exponent 2. So if 7 equals to 7, then our x minus 1 must also equal to what? 2. The whole of this exponent must equal to the second exponent. Then you can see that this becomes an equation where this will move to give us x equals to 2 plus 1. So x equals to what? 3. Now in solving exponential equation, after you express your bases and exponent, equating them, your result may either end in linear equation, quadratic equation, or a simultaneous equation. After the bases are gone, then we can say that this is just a linear equation. If I have example, so we can see that this is base 3 exponent 2x minus 5, 27. So still I can easily break 27 to base 3. As in, if I am multiplying 3 times 3 times 3, how many will I multiply? 3 times 3, 9. 9 times 3, 27. So in solving this, it becomes 3 exponent 2x minus 5 equals to 3 exponent what? 3. So since the base are equal, we equate the exponent. That simply means 2x minus 5 is equal to what? 3. Which is just a linear equation. This will have to be transposed to this side. We are going to add 5 to both sides. So 2x equals to 5 plus this is what? 8. What do I need? I need the x. So I divide both sides by what? 2. So 2x over 2, 8 over 2, make your x equals to what? 4. It means the value of x that make this statement true is what? 4. Alright. Then the second one. Don't forget this is 1 over 32 exponent y, which is also a fraction. We are told in the second step that we are to break all the numbers into exponent and bases and equate them using the laws. There is a law of a property of reciprocal, but if I like, I have to try and see, can I break 32, 256 into equal base? We are using prime numbers, so we are going to use 2 as the first number. 2 times 2 5 times will give us 32. So this is going to be 1 over 2 exponent what? 5. There is already y there to multiply. Equals to, then 2 exponent what? Will give me 256. That will also be 8 times. If you keep on multiplying, you get it 8 times. That will be 2 exponent what? 8. So per the law, or per the property, if I have a exponent, or let me take it for negative side, a exponent negative n, that gives me 1 over a exponent n. Don't forget this is the same as this. A exponent n, 2 exponent become negative of the exponent. So that simply means that here will become 2 exponent minus 5y equals to 2 exponent what? 8. So since the base are the same, we equate the exponent. So minus 5y equals to what? 8. We are looking for y, so we divide through by the coefficient. So we are going to have minus 5y. So this will just give us y equals to minus 8 over what? 5. Alright, so these are just the 3 steps that we follow in solving exponential equation. So take your time. When a number is given to you, try to see how many times can the base which is going to be in one of the two sides. One will carry the prime number that you are looking for. Then find it in terms of a base and exponent. Equate the exponent, then you are good to go. Alright, thank you for watching. If you find this educative, please like the video, share with your colleagues, and leave your comment as we get interactive. Don't forget to subscribe if you are new. See you as we get interactive.